title you could use the lookup if you want to try to find videos on it. It's also called, and this is the way I think of it, but I think they use this word maybe in another. If they use it in lesson. Oh no. It's also called, and I'll write this up. It's called partitioning line segments. So let me get that, and then I'll write that word up there. So this is the other thing you can write for your. I don't know why mine does this. Yeah. I can't get to the little thing that lets me get more room. Oh, here. Try it. So here's the other title of it you can do. So you can also look up, this is what I've always called it. So again, we're dealing with line segments. That means we have two endpoints. What we're trying to do is put a third point, or not really put it on the line, because remember, a line is already made up of points. We're trying to identify the point that is somewhere on the line based on the instructions they give us. So for example, as a simple version, they may say, where would the point that is, and this is not the language they're going to use, but I'm changing it for now until we get into the lesson. Where is the point that is halfway between the two endpoints? So you got to figure out where that would go. And halfway is pretty easy, but for some reason they don't even start with halfway. They start with the harder ones, but so that's the lesson that we're doing, or you, like I said, it says using ratios. First of all, though, what's a ratio? Ratio. I would say ratio. That's it. What's a ratio?
For every one of this, there is that.
All right, so that's the way we would say it, but I'm not sure that explaining what it is.
Oh, but it's basically, yeah. I lost it.
It's kind of it. It can be thought of as a percentage. What's the other thing that we think of as before percentages? Decimal works, but there's a better one. But so again, what's related to percentages and decimal? It's the one thing. Fractions. It's kind of like a fraction of something. It's sort of written different, but it is very strongly related to fractions, which right there. I'm going to give you a little example. Raise your hand. First of all, if you cook, you ever help your mom cook? All right, you guys, this will be no problem for you at all. If you don't cook, I'll give you some other examples that should explain it. But you do need to understand, how does a ratio differ from a fraction? But then how is it also kind of, so how do you take a ratio and convert it to a fraction? Basically, that's what you really need. What's distance? Kind of hard to find distance without using it. Yeah, you could say how far, or you could say what is the length of something, really. Like you're going on a trip, the distance you travel is the length of that trip. So distance is really just length. When we're dealing with line segments and we say length, that's really just distance. How far is it from here to here? So how would we figure that out? If we had a number line, let's start with a number line. Like if I said, I'm trying to remember which way it is. I think it's this way. Oh, no. If I said what is the length of that? How would you figure that out? I don't have any numbers. How would I figure it out? What do you mean? I know, we can't actually use the points. What would we use?
And I'll give you a number in that sense.
So if I don't have any numbers, I just count the little segments. That's what length is going to typically be. So if I'm looking at a line segment with no numbers, the length is just basically how many little line segments. 1, 2, 3. So a little line segment is, so I'm going to put a little mark. 1, 2. My board is not cooperating very well today, so I'll do my best. So we would say the length of that is 5. There's 5 little singular line segments. Now, it is key to remember, they're all the same length. There's nothing showing that. I don't even think we've talked really about congruence marks yet. I don't know if I did in one class. I don't remember which class it was, but we're going to come back to it. So I just decided not to worry about it. But you do need to understand every single one of those sections is the same length. They don't give you any other information. So all of these are the same length. It's divided into equal sections when we talk about partitioning. And again, partitioning means splitting it into equal segments. But yeah, if there are no numbers, then you just have to count the individual segments. What was the rest of it? So if you do have numbers, Neo, you just kind of said it. If you do have numbers and now we don't have segments, I don't have any little hash marks to tell me how many segments, that's when we would just subtract. So length or distance is really just subtraction. If there's a negative number, you got to be careful about your subtraction with negative numbers because that can get tricky a little bit. What's a midpoint? Yeah, it splits it in half. So if I have this ruler and I want to find the midpoint, I'd have to find the point that splits this into 2 equal halves. That's a midpoint. I can't fold it over, but normally if you fold something over on top of itself, that'll split it in like a string or that, or even a paper. That'll split it exactly in half. If you fold something in half, then you're splitting it in half. All right, so I think that was everything there. So let's talk about ratios and fractions, how they're related. If I have that's marbles up there, blue and the green stuff. How many blue marbles? 5, right? How many green marbles? How to do this? Oh, I can't get to the bottom thing to scroll. Shoot. It drives me crazy. So when we're talking about a ratio, we would say the ratio of blue to green is 5:3. I just put the numbers in order of what the colors were. So blue was the first color mentioned. Blue was the first color mentioned. Green was the second color mentioned. So I write the number 5 first. Drive me crazy. So I write the number 5 first. I'm gonna have to try to fix the board. And then the number 3 second, because again, blue was mentioned first. So I put the 5 blue ones first. Green was mentioned second. So I put the 3 green ones second. And this is the way you would write it. That little, what's in between the 5 and the 3? You know, what's that little guy called?
Semicolon.
It's not a semicolon, it's actually just a colon. So you put that in between for a ratio. You put a colon, C-O-L-O-N if you want to write it down. It doesn't matter what it's called really, as long as you understand that's the way you write it with that symbol. So that is a ratio of 5 blue marbles to 3 green marbles. Well, if I don't do that really, really slowly, it normally doesn't fix it. Hopefully that fixed it, and it won't last long. Like I had to do that 3 or 4 times just in the last class. So now though, how does that relate to a fraction? What in the world would I?
3/5.
But I wouldn't want to really, that's still a ratio.
3.
That's still.
To a fraction. Using the section formula.
Well, let's not worry about a formula. Let's just think about, let's try to figure it out. Oh, cap that and put it up, please, Marianne. How would a fraction come into play? But I could say 5/3. That would make it a fraction, but that's still actually a ratio. It's still 5 blue marbles to 3 green marbles. That way, not really a fraction. Anybody want to take a shot? How many of the marbles are blue? How many marbles do I have? What you said? How many marbles do I have?
You can.
Now, what do you think?
It can like, since there's 8 total marbles, you can make a fraction using a specific color. So there's 5 blue marbles and there's 8 total marbles. Out of those 8 total, out of those 8 marbles, there is 5 blue marbles.
So here's how you make a fraction. The total will always go on the bottom. So whatever item you're talking about, and I'm gonna do a couple other examples, the total will go on the bottom. And then the top part's kind of hard to put it in words, so I'm gonna put some words there, but you need to use your own words. If you understand mine, great. But don't write mine down if you don't know what I'm talking about. Whatever the number of pieces are, like how many pieces you have for what you're talking about. So again, that's got to go into your own words. Maybe just do all these examples and that might explain it to you. But if I wanted to know what is the fraction of blue marble, then I would say how many blue marbles go on top. So again, it's the number. Oh boy, it's hard, so hard to put it into words. Number of, well, but I teach math, they're not words. Number of pieces for that item, I guess. I don't know for what, because again, it could be all kind of for the item. I don't know. But again, this is where you need to have some examples because it's easier to just have examples. So for example, for the blue marbles, if I'm talking about blue marbles, I would say, well, there's 5 blue marbles out of 8. So I would say, if I wanted to say that in words, 5/8 of the marbles are blue. That's a fraction. So a ratio uses some of the same numbers, but I'm talking about the individual components of it. So the blue versus relative to the green. For a fraction, I'm talking about one of the individual components relative to all of them, to the total. That's what a fraction is. A fraction is a part of a whole. A ratio is not a part of a whole. It's comparing the parts to each other. Well, that's actually the best definition. So a ratio compares the parts to each other. A fraction compares one of the parts to the whole. So in this case, the whole is all 8 marbles, and I'm comparing the blue. So 5/8 of the marbles are blue. If I wanted to do it with the green, I would say 3/8 of the marbles are green. But again, the ratio is still 5 blue to 3 green, comparing the parts to each other. The ratio compares the parts to each other, like 5 to 3, the blue to the green. A fraction compares one of the parts to the whole. So just the blue compared to the total of 8, or just the green, which would be 3, compared to the total of 8. Part of a fraction is a part of a whole. Again, I'm not worried about definitions. You need to understand how to convert a ratio into fraction.
Whichever one is actually goes over the top.
So now look at that. I want you to convert. I want to know what fraction of the pizza is cheese. The red dots represent pepperoni. The rest of the pizza is cheese.
Don't like it. Or stuff up the pizza.
So again, the ratio is I have 1 piece of pepperoni, so that's 1 piece of pepperoni to 3 pieces of cheese. I want to know what fraction of the pizza is cheese. So you guys create that. Try it on your own. Just try it on your own. We're gonna go over another one that's not the last one. So first try this one on your own. If you don't get it, I'll give you one more that you can try on your own again. And by then I think you'll have it. So 1, and use the picture, 1 piece is pepperoni, 3 pieces are cheese. What fraction of the pizza is cheese? All right, so by a show of hands, quickly, you said 1/4 of the pizza is cheese, raise your hand. You said 2/4, raise your hand. You said 3/4, raise your hand. You said 4/4, raise your hand. All right, so let's talk about it. I said I want to talk about cheese. So I need to think, okay, well, actually, I'm going to start different. First, I need to think about what's the whole. The whole is always the bottom part. So it's again, total on the bottom. And then the number of pieces. I'm just going to leave it at number of pieces. So in this case, number of pieces that are cheese. That's what my fraction will be. So I just need to say, okay, well, how many total pieces were there? How many total pieces were there? Pieces, I'm saying. 4 pieces, right? In that particular case. So that's my total. How many of those pieces were cheese? So 3/4 of the pizza was cheese. That's your fraction. You can then convert fraction into a decimal or into a percentage, and you'd say 75% of the pizza was cheese, but we're not getting into that, but just as a reminder. All right, one more, and this is the most common one. This is the one I started with for those of you that bake. Oh man, God, how do I get rid of that stuff? I really don't know. But yeah. Oh, I guess I can zoom out. I won't get rid of it, but it'll at least show it. Oh, I won't. Ah. Shoot. I have never been able to figure out how to get rid of that. Oh, actually, yeah, I can. This will get rid of it permanently, but. Oh, actually, that worked. Never mind. Wait. Yeah, there we go. All right, that one. Not what I was trying to do. So again, now you're cooking. You're using 2 different kinds of sugar in this. 1 cup is brown, 2 cups are white sugar. I want to know what fraction of your whatever you're cooking, what fraction is brown sugar? What fraction is brown sugar? There's your ratio. Don't say it out loud. Just do it on your own. You don't even have to write it down if you don't want to. As long as you can convert a ratio. Actually, tell me what fraction is brown and then what fraction is then what is the, I guess, white sugar you call it. I don't cook, so. So tell me both fractions. Your fraction should always add up to 1. Because remember, we're talking about one whole. It's a part of a whole. So your whatever 2 fractions you have, if you add those up in this problem, it should equal 1. All right, so for the brown, what is it? 1/3, right? We have a total cups of sugar. So the total cups of sugar is 3, right? I have 1 cup of brown, 2 cups of white. So the total is 3. Well, out of that 3, how many are brown? Well, 1/3. So that's the brown. That's the brown. And then for the white, it'd be 2 of them are white. Still have a total of 3. Nothing changes with the total. Oh yeah, you need to grab a book, Angel, and pages 23 through 40. 23 through 40. Tear them out. Be careful because they
rip
pretty easily, but they are perforated. So if you take your time, tear them out like 3 or 4 or 5 pages at a time. Don't try to tear them all at once. All right. So that's the first concept you need to understand. How do we convert a ratio into a fraction? I think we're probably pretty good on that. That's not the hard part. So here's what we're going to do now. I want you to find or place or really identify, not really place, because remember, a line is already an infinite number of points. We're going to find the point on this line that will divide that line into a ratio of 3 to 7. What in the world does that mean? What does that mean? What does that mean? What does that mean? Dylan, what do you think that means? I think it's time to wake up. Right? iPhone hours of Dylan. So, what does that mean we're really doing here? This is actually, I'm giving you one that you don't even really have to do any math on,
Trying
if you get the concept.
to get, line to be divided into into two segments, where one is 3 units long and the other is 7 units long.
In this case, that is absolutely correct. So let's talk about this. This is the easiest one you will get, and you will see this, like this. Sometimes I give you problems that are like easier than what you would see on a district test. You'll see this on a district test. This line segment, if you count segments, like the little teeny tiny segments, you'll notice there are 10 little segments. 1, 2, I guess I can number them. Here, I'll do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're, so again, you'll notice how many total parts, like what is the whole in this particular problem using the ratio? What's the whole, the bottom part, the total part?
10 units.
10, right? Because just like we said, how many total cups of sugar, we just added the 2 cups of, or the 1 plus the 2 gave us 3. Just like in the pizza, we said there were 4 total pieces of pizza. We added the 1 pepperoni piece plus the 3 cheese pieces. It's the same thing for a line segment. If we want a ratio of 3 to 7, then there's 10 total segments in that line.
Yep.
So if we know there's 10 total segments and we just want a ratio of 3 to 7, we just need to put a point that will give us 3 segments in one part of the line and then 7 in the other part. We just need to split that line into 3 and 7. Again, this is the simplest version that you get. Not going to spend a bunch of time on it, so if you're confused, I guarantee you're not the only one. Somebody else is also confused, even though nobody's saying anything. A ratio of 3 to 7 just means create 2 lines. So think of a straw. I think I used a straw in this class. If I had a straw that was representing this, and I wanted one straw to be 3 little segments and 1 to be 7, but I'm starting with the whole straw, I'd just cut it, and I'd cut 3 segments off, and then I have 3 and 7. That's all we're doing. I want to put a point, colors, or not really put a point. I want to identify the point that splits that big line segment into 3 and 1, 2. Now I'm not using the 4, 5, 6 because now it's 2 different segments. So it'd be 1, 2, 3, 4, 5, 6, 7. That's where the point would go. So that's the most basic problem. And you will, excuse me, you will see that, I think, on the district test, something where you just have to do that. Pretty basic. The number of whole parts matches up. So I want you guys to do the next one. You can think about it. You can write it down. I would say write one down, draw out. So you'll notice if you want to split something into 10 segments, you only need 9 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't think there's anything in your book to do for this. We'll get to using your book pages, but if you want to just create it really quickly, just to make sure you have something in your notes to use, even though I don't know if the book does anything like this or not. Yeah, they got that. It's actually before example 1, they kind of do it, but they give you a formula, and we're not using the formula even for this. We're just gonna figure it out. Formulas are great until you don't have the formula, and then what do you do? So I would prefer you understand how to do it. We will use sort of a formula later, but not yet. I'm going to try to teach you a way to just figure it out. Then I'll give you the formula if you really think you can memorize it. All right, so first thing I want to ask you is this. Think about where your point would be before you even start figuring anything out. If I want to split that line into a ratio of 9 to 1, so I'm going to create 2 from the one big segment. I'm going to create 2 segments. And you notice here, the first segment was the small. It was the 3 because it matched up with where the numbers were in the ratio. So the first segment was 3, second was 4. So this one was shorter than the second. So you got to keep that concept in mind that the first number basically kind of tells you about how long the first part of the line will be. And then the second number tells you about how long the second part of the line will be. If the first number is smaller, then the first section is going to be smaller. If the second number is bigger, then the second section is going to be bigger. So what is my line going to look like? Like, where is the point about going to fall? I mean, you should know exactly what's going to fall, but you won't always. So what about the nines? Big number, right? So what does that mean the first part of the segment is going to be? Or it's going to be big, right? It's going to be way bigger than the last one's going to be super teeny tiny. And the first section is going to be almost the whole line. Because out of this particular line, I've got 10 parts, because I just add up the two numbers in the ratio, which means there's a total of 10 segments. Well, 9 of the segments are going to be in the first part, and only one of them is going to be in the second part. So in this case, it's pretty easy because the number of segments matches up exactly with the ratio. So I would just count 9 segments. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I then put my point, that should mean that I have 1 left over to match up with a 1. And sure enough, I do. So again, that was pretty easy. Not too bad. Now let's go to one that's a little tricky. Still not hard. Still not super difficult, but more difficult than those two. And I want you to try this one. What about that one? Try to do it in your head, because I want everybody to think about it individually, not just listening to what somebody else is saying. Now my totals don't match up. I'm telling you, I've only got 5 total sections. But wait a minute, if I look down here, that's way more than 5 total sections. So I want you to think about how you can still actually matches up pretty well. But you just got to think about how can I get that one to match up. Again, not out loud, because I want everybody trying to figure it out. I'll give you a minute to think about it. I will tell you though, this one is still one that you can just kind of visually do. We still don't need any formulas or numbers yet. So, nope. I mean, I do, but I don't want you to use that. I want you thinking about the concept. Yeah, it doesn't have to be a perfectly straight line, and as long as you understand that the segments are even. And again, it's still 9 dashes, so there's still 10 total segments. I will tell you that. There's only 5 though in the ratio. I have 2 to 3, which means there's only 5 in the total using the ratio, but there's 10 in the total down here. You got to figure out how to take that into account. Volleyball tonight, varsity and JV, if you know anybody on those. I think it starts at 6:30 maybe. I had a schedule somewhere that they gave me. Not sure what to do with it. For the other one that was 9 and 1.
Yeah.
So this is 9 little segments, right? Yeah. So if we wanted a ratio of 9 segments to 1 segment. So we just put a point on the line where we had 9 segments to 1 segment.
Oh, okay.
Or you could think of it as 9 out of 10 for if you wanted to think of it as a fraction. So this is 9 out of the 10 total for the first segment. Either way works for those types of problems. So here's my first question to you. Not quite as easy, but there's one thing that you should definitely get from this particular concept. You should know if I think, okay, well, I see this line, boy, if I just kind of estimate the midpoint, what do we say the midpoint is? It's like the middle, the exact middle. The midpoint would be somewhere like in here. Somewhere, maybe it's right on that, maybe it's a little left of it, a little right of it, somewhere in there. So that will split this line into 2 smaller lines. Are they going to be equal? Are those 2 smaller ones going to be the same exact size, do you think? Raise your hand if you're like, yeah, I think they'll be the same size. And this is based on this ratio right here, ratio of 2 to 3. Are they going to be the same size? Raise your hand. Everybody, boom, raise your hand. You think yes? Raise your hand if you think no. Got a lot of people not raising their hands. I'm assuming you have no idea. I need to know. So if you have no idea, raise your hand. Chad, you're not raising your hand. You're no idea. Yep. So I'm using this ratio and I'm just trying to think about where is the point going to be? Like, is it going to be way down here like it was in this one? Is it going to be way over here? Is it going to be right in the middle? Is it going to be a little left middle, a little right middle? I'm just trying to, first of all, come up with where I think it might be about, just simply based on that ratio. So again, let's do it again. Do you think it's going to be, so again, I'm saying the first segment. Oh, no, this is what I'm saying. Never mind. I said, do you think that when I do find where I think the point's going to be, or when I know where the point's going to be, do you think that the two segments that are created will be the same length? If you think yes, they will be the same length, raise your hand. If you think no, they will not be the same length, raise your hand. If you have no idea, raise your hand. All right. So here's the thing. If this ratio has two different numbers, like it's not 2 and 2 or 3 and 3, they won't be the same length. If it did have the same numbers, then they would be the same length. Because you're basically saying, I want, like up here, we said, I want a ratio of 9 segments to 1 segment. If I would have said 5 to 5, that would have meant the first little section is 5, the second little section is 5. So that's when they would be equals, if you have the same number in the ratio. I don't have the same number here. Clearly, they weren't the same length. I don't have the same number here. So even though it doesn't match the 10, it doesn't matter. I know at least it's not going to be the same length because I have different numbers here. Now, what do I know then when I do figure out where it goes? What's going to be true about the first segment versus the second segment? Morgan, what do you think? What's going to be true? Like if I put a point randomly right here, can that be right? Why not? Why can't that be right? How do you know that's not right? Absolutely. When I put my point on that line. So the reason I'm telling you this is sometimes the tests are multiple choice for the district. Even if you can't figure out the number, you better be able to tell me that's not right. I don't know where it goes, but I know that's not right because this number is smaller. That means this part of the line can't be bigger than the second part of the line. If this number is smaller, then that left segment has to be smaller, wherever the point is. Kind of like up here, this number was way bigger, right? Well, then the left segment was way bigger. This was super tiny relative to 9, so it was super tiny on the right. So sometimes passing these tests, because a lot of you still need to meet your algebra requirement. I haven't actually looked to see who has it and who hasn't, but I'm guessing a lot of you still need to. Sometimes it's just a matter of eliminating the wrong answers and then making your best educated guess on some problems. And this is one where an educated guess will probably go a long way. I know that that first section has to be smaller than the second section because I only want a ratio of 2 segments to 3 segments, which we'll get to now where we actually put. Can I split it up though? Like, can I say just, all right, well then if it says 2 to 3, I just need 2 segments, right? I just need 2 segments there, right? Just like we did in all the others, is that right?
No, that's not.
Again, that doesn't make any sense because these numbers, even though, yeah, the first segment is smaller than the second, these are really close to each other. So therefore, the length of the 2 segments should be a little closer to each other. I shouldn't have a teeny tiny one and a big one. Now up here I should, because I got a big number and a really tiny number. So yeah, I got a big segment and a little tiny segment. Down here though, that shouldn't happen. That doesn't make sense. Again, that is not a viable solution. Even if I don't know where it goes exactly, that's not right. Because this segment should be a lot closer in length to this segment than what I just did. So that can't be right. So now let's talk about how we actually do it. What would be a concept we could maybe do? Like, what's a way to possibly do this?
I did 2 and 3. And the dash.
Say it again.
Wait, I dash yourself a line and keep adding 1, 2, like 1, 2, find the middle.
Not sure I follow that. So if you got this same answer, then you go with whatever works for you, because you might be saying the same thing I'm going to say, because sometimes we explain things differently. So if you got the same answer, then just go with what you got. That's the good thing about the new standards is they're not going to force you to find the answer any certain way. It says you choose the way that works for you. Unlike before, like I'll give you an example, just you may not even remember this, but there was a section called system of equations that you solve. You could solve it by graphing, you could solve it by elimination, or you could solve it by substitution. And we had to quiz you on every single thing. You had to know how to do substitution, how to do elimination, how to graph them. Now they don't care. They're like, you need to get to the answer. I don't care which way you do it. So this is the same thing. If you've got a way that works, I don't care how you do it. You need to just be able to get to the answer. So how many parts, how many total parts are we saying there are here? Based on the ratio? Only 5, right? Well, what's the problem with our line?
There's not.
Too many.
There's 10, right?
But
But could we make it into only 5? Like, is 10 divisible by 5? If your numbers are divisible evenly, which they are, 10 divided by 5 is 2. And again, I'm not even worried about you knowing which, but if you just know the number of segments that I have in my figure is evenly divisible by that, then there's something you can do to make it into only 5 sections. How can I make it into only 5 sections?
just combine segments into even parts. So for sections 1 and 2, you can just combine them to make 1. For 2 and 3, you can combine them to make 2, and so on until you finish off the line segment. So
that 2 is the magic number. When I divided 10 by 2, what that's telling me is make the segments into 2 little segments instead of keeping it at 1. So if I now use the blue lines, you'll notice I do have 5 segments. And they're all equal because these 2 are equal to these 2 and equal to those 2. So they're still all equal. But now I have 1 segment, 2 segments, 3 segments, 4 segments, 5 segments. So I can change I didn't really change anything. I mean, I'm just kind of ignoring all of these little black lines and just really focused on where I put the blue lines. I didn't move anything around. I mean, there was still a black line underneath all those blue lines. Not my class. Now that I've done that, again, it's the same problem. I just say, okay, how many segments do I want in the first? Well, now that's 1 segment here. So 1 segment, 2 segments. So that means my point goes there. And then now I have 1, 2, 3 on the right. So again, that is one method to solve. This one. Yeah, so trade your phone out for the pass. And that all involves no number. Like you'll notice, we didn't have any numbers, so there's no way we could really do math on those. When we start doing problems with numbers, you can still do this. This still works for many of them, not all of them. There will be some where that's not possible to do because you're going to deal with fractions. And when you start dealing with fractions, the line segments don't come out to be exactly round numbers, so you can't really do that same process, but there'll be a lot of them where that will work, even though you're dealing with numbers instead of just segments with no numbers. Any questions on that though? Let's move on. So let's look at the book stuff now. I don't know if they gave you any in the book that are like that, but the book now gets into doing it with ratios and actual numbers. So look at the first example. Locate a point on a number line when given a ratio. I'm just going to, well, no, let's go ahead and do this. How long is that line? Wait, which one? How long did you say? So how long is the segment AC? How are you getting 13? Oh, great question. Let's talk about this. What did we say distance was? Length or distance is what? There's a math operation it is. You don't know this, you need to write it down. After I wake you two up, that's going home. And this is the only day for this lesson, so you miss it today, you're catching up on your own. And like I said, a lot of you already are making up a retake for one quiz. What math operation did we say gets us the distance or length? That's not a math operation. You just did it in the bell word, people. I gave you this. I said, how long is that? How long is that?
Oh.
Yeah, subtraction. Distance or length is subtraction. So we don't just count the segments, although we can, but you can't count the dashes. You have to count the segment itself. So be very careful because you should get 12. Did you look back?
Yeah.
So it's, if you have numbers, it's safer to just subtract. And in this case, because there's a negative, you have to use a little bit, I guess, a little bit more complex math. I don't want to show you that yet. So we say 7 subtract -5 equals, and how do we do 7 subtract a negative? You will actually have calculator. Yeah, actually, you'll have calculator this time, so I don't care.
7 plus 5.
It would flip to 7, but it'd be 12. You'll have a actually, you're gonna need calculators, so we'll grab those in a minute. So yeah, you'll just do that in a calculator. You do have to know how to input it into a calculator because they work differently depending on the calculator you use. But the length of that segment is 12. So now it says I want a point on that line. So I want to identify the point between A and C that is divides it in a ratio of 3 to 4. Now, so the ratio is saying that you have 7 parts, right? Because there's a 3 and a 4. So 3 out of 7 or 4 out of 7. But we have a line that's 12. So, and 12 is not divisible evenly by 7. So this is where we get to the hard problem. This is the difficult one. Nothing comes out even. I can't just divide this line into equal sections of 7 and be able to figure it out. So now we're going to have to use a formula. And again, I'm not really giving you a specific formula. I'm going to give you steps. They give you a formula. If you understand that formula and you want to plug numbers in, again, I don't know that you'll get that formula though on the EOC or on the district test. So you may, if you can't memorize it, you may be out of luck. But if you can understand the process, then I think you'll be able to duplicate it. So here's what you need to do. Your first, about where is the point going to be? Let's try to come up with what we think is a viable answer first. If I'm dividing it into a ratio of 3 to 4, what is that? Where does that mean about the point's going to be? Like,
It's to be and closer to the middle than it is going to be to the end, but not, it is not be the midpoint.
remember, if the two numbers are pretty close to each other, like 3 and 4 is pretty close to each other, then the point's going to be about in the middle. If one number is way bigger than the other, then the point's going to be more toward one of the ends, depending on whether the bigger number is first or second. So that's the first thing you got to ask yourself. Is the point going to be more way over to the left, more in the middle, or more way over on the right? In this case, the 3 and the 4 are pretty close to each other. So that means the point's going to be pretty close to the middle. Because I want the line. So which part of the line is going to be bigger? The first section, like the left section, or the right section? Bryn, what do you think? If the 3 is first and then the 4, is the left segment going to be bigger or smaller than the right segment? Oh, yeah, the 3 is smaller than the 4, so the left segment is going to be smaller than the right segment. So I already know for this particular problem, my point is going to be a little left of the middle. Where is the middle at? What would you say the middle is approximately? You can figure it out, but for some reason they didn't do midpoint first. I wish they would have. I guess I could have. Where is the middle going to be if I got a -5 on one end and a 7 on the other end? How many total pieces are there? How many total segments did we say?
Would that be about 1?
Well, let's think about it. How many total segments did we say are in there? What's the length of that line? 12, right? So what would half of 12 be? So the middle is going to be makes the left 6 and the right 6. So just count out 6 segments on the left. So 6 segments. Boy, I wish I had. Oh, I do have this. Hold on. I can put this up. You guys count it out while I pull up the online book. I meant to have the online book open. I totally forgot. I was having so many issues with my smartboard. I totally forgot to open it up. So again, you guys try to figure out where it is. You should, if you say, okay, this point right here splits it into 6 and 6, then that's the midpoint. There's a formula to it also that we'll get into eventually. I might give it to you in a second. Actually, I am going to give it. Well, yeah, this would work. What can anybody? What number did you get? Raise your hand if you got a number. Like what point? Where did you put your point? What number?
1.
On 1. Is that what everybody got?
Yeah.
Here's what I want you to do. Add 7 plus -5. So not subtract this time. 7 plus -5. What do you get? Divide that by 2. What do you get? Ta-da! That's the formula for midpoint. You add the 2 endpoints and you divide by 2. That's all you got to do for a midpoint. They have a whole lesson on it. Well, they have other stuff in it, I guess. But so if you want to write that formula down for midpoint, add the 2 endpoints together and divide by 2. And it's always divide by 2. That never changes. Let's see if I here, yeah. All right. So let's go to what problem is this? Example 1. Locating points. They did that. So I guess next page.
Check out the 2 ends to divide by 2.
Yep, whatever the number is on the 2 endpoints. So 7 and -5. If you add them together, you get 2. Wait, that's not the. Oh, that's the check. So where was the? I guess it was at the bottom. Maybe not. Oh, there we go. It just hadn't popped up. There we go. So now, so if I ever want to find the midpoint to just kind of make a good guess of where I'm actually going to put my point, I could always do that. Add the 2 endpoints. I could say, okay, well, my midpoint then is 7 plus -5. That's 2. 2 divided by 2 is 1. So that right there is my midpoint. That's not what they're asking me for, but I just want to get an idea of where is my point going to fall. Well, the ratio it says that I need is 3 to 4. So that means the first segment's going to be smaller than the second segment. So that means I'm guessing somewhere, if I want 3 to 4, that's still pretty close to the same length. I'm guessing somewhere in that range. Again, just totally, not totally guessing, it's an educated guess, but that's where I'm thinking. I think my answer is going to be somewhere between -1 and 1. Probably, maybe even somewhere between -1 and 0 when I get it. So if I go through all my math and I don't get something in there, I need to think to myself, okay, something might be wrong. Either I did some math wrong or I wasn't thinking right somewhere in the problem. Now let's try to figure that out. So here's your process. So I'll put this up on the screen, so I guess you don't have to write the whole process down right now. The first thing I need to do, I'm going to convert that ratio into a fraction. And I only need to convert it into one fraction using the first number. I hear things. Was it?
Okay.
I hear things all the time and think people are not. Oh, yes. Oh, Kristen. Very man. Best of luck. So what would the fraction be using that first number in the ratio? How many total parts are there that they want to split this line segment into?
There's
7 total parts, and I always pick the first number. I don't need to choose. It's always the first number. So you're always going to be using the first number to find the point. You could technically use the second number, but then you'd have to go from the back point. So I need 3/7. What did we say the length, the total length of the line was? 12, right? So I need to take this and multiply it times 12. You get calculators, so I'm not even going to go through how to multiply fractions. So I would now get, I'm going to have to maybe do this in the calculator myself. So that's gonna be 36/7. I'm gonna round it off. It's gonna be 5.14. So that's what 3/7 of 12 is. Of, if you don't remember this, by the way, of, the word of typically means to multiply. So 3/7 of the number 12 means 3/7 times 12. That might help you in some of the PSAT, SAT stuff as you guys take those. So now here's the next thing. So what is this telling me? Anybody have any idea what that told me? What did I just figure out? Did a lot of math. What in the world did that figure out? I'll give you a prize, for candy, or maybe even food for that. Tell me what I just solved for.
You solved for the, where the point is on the segments.
Use the ratio. No, well, actually, I converted the ratio to a fraction. No.
What the mid,
You solved,
Yeah. Because that wouldn't be the midpoint, which then the midpoint was gonna be at 1.
that
And clearly, I'm not gonna want to put the point there, right? That's, I didn't solve for where the point goes, because that would mean the point would be way over here. And that's not where my estimated circle was.
solved for the number of segments that, well, number of full and part of the segments that, if going from left to right, that the point will fall on.
There's an easier way to say that, but I'll give you credit for that. You want, do you like Lifesavers or Jolly Ranchers?
Jolly Ranchers,
What color?
right?
I'm gonna, oh, I don't know if that's cherry or that's water. Is watermelon okay, or you rather cherry? Oh, that one's came open, yeah, that whole, I need to take that whole mess out. Darker. That one I think is good. No? Is that it?
Yeah.
So I got it. So I'm gonna tell you again, I feel like you definitely got it, Lucas, but here's the easy version of what he just said. I just figured out how long the first segment. That's what I figured out. That's how long the first segment. Because didn't we say the first segment's gonna be a little smaller than the second, right? Because we said the 3 is a little smaller than the 4. How long is the second segment gonna be? If that's how long the first segment is, what would that make the second segment? You guys failed to do that, man. You just actually, that's quiz you should have had. So if you can't do that part, that's why we did the line segment stuff first. If the total is 12, if the first segment is 5.14, how long is the second segment? I'll let you guys do it. If you don't have a calculator, it still shouldn't take you a super long time. 5.14 is how long the first segment is. The whole segment we just calculated is just from 5 to 7 is 12. So how long is the second segment? No, it wouldn't be 4 point. Oh, so you used the wrong number. Yeah. So your thinking was correct, but you used the wrong number. The whole segment is 12, not 9. So if the whole segment is 12, which is, we just said 7 subtract -5, what's the second segment gonna be? If that's the first, what the length of the first segment is gonna be 5.14. Come on, people. That sounds a little better. 6.86, right?
Yep.
So we got. So the second segment is just 12 subtract 5.14, which is 6.86. And now you ask yourself, does that make sense? Does it make sense if I want a ratio of 3 to 4 that my first segment would be, so I'll even write them up here, 5.14, and this is length, to 6.86. Well, I would say, yeah, they're pretty close to each other, but the first one is definitely smaller than the second one. They both add up to 12, so I know they add up to the total length. That makes fantastic sense to me. But now the question is, where does that point go, right? How do we figure out where the point actually goes? Morgan's thinking it over. Jitsia, what do you think? I know how long the first segment needs to be. So what do I need to do to get
Find
the,
the middle from counting the left segment with 5.14.
do what?
From the left side,
Do we really need to count?
5.14 to the right and to the 15.86.
How do you count 0.14?
I figure out.
What's a better way to count than counting? I mean, you could count if it's
Round.
a
A better way
number.
to count
Round.
counting.
No, it can't round. It's gotta be exactly there.
Number
Estimating.
Oh, don't need to estimate.
mixed number.
What number am I starting at on the left?
Negative.
So how would I move from there 5 to the right? Or 5.14 to the right? Without, that's not counting. So distance is what we said. Math is distance.
By subtracting.
You're doing it the long way. That would work. Flip that math operation around. Don't do
By adding
subtracting.
5.14 to -5.
Ah,
We would just take the starting number. So if the first segment is gonna be a length of 5.4, I'm just starting it here and I'm adding 5.14 to it. You would have known that immediately if the first number was 0. You would have been able to say 0 plus 5.4 and you would have been like, yeah, you just add 5.4 to 0. For some reason though, when we start with a different number besides 0, we don't think about it. You're just adding to this number. That's your start point. Treat it like it was 0. Only it's not 0. You got to use that number instead of 0. And then you say, okay, well, if I need a length of 5.4 from here, I'm just going to add 5.14 from here, which would put me just at the edge of my circle that I estimated.
nice.
So there you go. So everything made sense. The first section was a little bit smaller than the second, but yet they were still kind of close together. It fell in the circle I estimated at the beginning. So I'm pretty confident that that was the right process. All right, so here's what I want you to do. Boy, we went super slow on that, but I think we covered a lot. Look at your pages and there's a practice page, which is, we only did one example, but we weren't going to do all of them anyway. Practice page. Forward. Oh, you guys see the practice page? I can't see it. I can't see without my glasses. Yeah, there you go. So you see where it says on page 27, example 1. Do number 1 through 6. We weren't going to do example 2 anyway. So I want you to practice 1 through 6 for a minute. I'll walk around, work with each other. Definitely check your answers with each other. You got answers, check them with somebody. I don't mind, as long as you work, I don't mind if you move around when I turn it over to independent practice. If there's somebody you know in here that you can work with well, just make sure you are working. That's the only key to that. And then again, I'll walk around and I'll help as well. But that's the process. Is anybody, you should have written all of this on your pages. So I'm going to move off of this and I'm going to kind of show you the whole process. If I can find the page. Oh, wrong one. So that's the steps. Again, I'm not big on you memorizing stuff and I'm not going to do open note stuff like I used to. That's why I used to have them copy a bunch of stuff down. You convert the ratio into a fraction. You only use the first number of the ratio. Oh, if you already have a fraction, you don't need to do that. Like if they would have said, find the point that is 3/7 of the way to the end point or something like that. Well, you already have 3/7. You don't need to convert it anymore. It's already a fraction. So you convert it into a fraction by taking the first number and putting it over the two numbers together in the ratio. So in our case, we did a ratio of 3 to 4 created the fraction of 3/7. The first number over the total, the 3 and the 4 added together. Now you find the length of the line. That's just subtraction. You just take the end number and subtract the beginning number, or the end point and subtract the beginning point, the start point. Then we multiply the fraction that we came up with times however the line is, the segment is. That will tell us how long the first little segment is going to be. So then we just add that length to the beginning number. So that's the 4 steps right there for the, and I haven't even read the questions. They might be asking you little individual baby steps to it, but. 7, so find the corner point. So yeah, you're doing the same thing in number 1 and 2. And then, yeah, you're doing the same. Oh, what's going to happen in 5? What is going on in 5? Oh, I know. I'm asking you what's going on in 5. Look at 5. What's
It's basically, basically saying that it's a 1-to-1 ratio, which is basically it's just.
so what's true about that? You can do the same exact steps we just did, but there's something else that you could do in that one. If the ratio is 1-to-1, what does that mean? First of all,
It's
if both numbers are the same. It means the left section, when you split it, will be the same length as the right, correct? What did we say that was the definition of when the left section equals the right section? That's the midpoint. You could just use the midpoint formula, which is just add the 2 endpoints and divide by 2, and that'll get you that same answer. So remember that if you're ever doing the midpoint, they may not specifically say midpoint. They may give you a ratio of 1-to-1 or 2-to-2 or 3-to-3. Anytime the numbers are the same, you're just finding the midpoint. But again, you can still do it this way and it'll work. Same steps. It would be 1/2 would be your fraction. All right, so keep working. I'm going to try to go over one of the other examples in about 10 minutes. Let's get out at 10:49. And even though we may not be able to practice it a lot, I want you to see one of the other examples, although we may have gone over. Yeah, I have to go over a coordinate plane example for sure. Yeah, so that'll be the only other one we'll do. Yeah, that'll work. We're not sure. I didn't do a lot of word problem stuff on it, and you will definitely see some word problems, and they'll give you a one where you're not given the like a picture of the line already created. You would have to create that yourself, but then everything else is still the same.
Do you count like basic or don't?
Well, if you have numbers, you shouldn't be counting at all. When you're trying to find the distance or the length of the line segment, don't count segments if you have numbers. What do? How do you find the length of? Somewhere. I guess it was bellwork. How do you find the length of that line segment when there's no segments? But again, but how do you find the length of that line segment? And then huh? Yeah, so you could, are you trying to find the length of that line?
I'm just like, that's just 3.
Oh, I want you to do these using the ratios, not the dividing it into segments. Let's see if it would even work. 18 subtract 2 is 16. It would work in this, because if you'll notice, for the very first one, the length of the line. So the length of the line in the first one is 16. Right? Because it's 18 subtract 2. The ratio, is it 3-to-1 or 1-to-3?
3-to-1.
So the ratio is 3-to-1. Well, and that means how many total parts are going to be in it if it's 3-to-1? Like what's the bottom part of the fraction?
4.
It's 4, right? We said we just add these together to get the bottom part. So the first part of the segment needs to be 3/4 of the total segment. We also said, though, if this length of the segment is evenly divisible by 4, which that is, there is a way to just divide it up into equal segments. So if you want to try that, I guess, again, I don't care how you get the right answer. The challenge with that is that won't always work. Doing it the other way will always work. But if you want to try it that way, I don't care how you try it. So if you want to try to divide it into 4 equal size sections, you would basically be dividing it into sections that have 4 little segments in it. With 16 divided by 4, it gives you 4 little segments. So if you divide it into 4, 4, 4, 4, that should come out nice and even. You want to try that? You see what I'm saying?
Yeah.
That would be one big segment. That would be one big, 1, 2, 4. Now you have 4 made up of 4 little tiny segments.
I think
This is the length of the total line, right?
oh, yeah.
This is how many total parts you need in each segment. So 16 divided by 4 gives me 4. So each section, each equal section will have 4 little segments in it. If you're not following that though, you can't do that on your own. Like you can't duplicate what I just did, then you need to just practice the other method, because that's the method that sometimes you have to use. Because you can't divide it into equal size little segments. Well, you technically can. Oh, if you want a calculator, grab a calculator. Wake up, man, oh man. You guys are in for some. Wait till people are scrambling at the end of the quarter. I get to refer back to those days when people had their heads down.
Are you happy about that?
Okay.
Are you happy?
Well, I'm not happy. You're right. I'm not happy that people are, but it does amuse me in a way that people think that they can put their head down and then all of a sudden somehow pull their grade out at the end of the quarter. I get the emails all the time, like every quarter, some students, what can I do to get my grade up? My response is, well, it's too late now. Good luck next quarter. Although I don't say it like that. That's the gist of it. Once you get to a certain point, there's nothing you can do. They give you a grade for the whole quarter, not just for a week or two of the quarter. So you need to be working the whole quarter. Everything all right with you, by the way, Andy?
Oh, what's it called? Somebody had hit my car last week. Yeah, it's good.
Somebody you knew or?
No, it was just in there.
Oh, okay. I mean, it's bad no matter what. Obviously, it's worse if it's somebody you know. Is the car okay? I'm hoping that's a joke. If it is, pretty funny. Any other questions on that? I'm gonna give you a couple more minutes to try 1 or 2 problems, and then I'm gonna show you how to do the next example, and then you'll go back to working on whichever ones you want to work on. And yeah, I don't remember which direction it was, but I'll find it. Yeah, I mean, the steps work. And if you do them enough, if you practice, I hate memorization, but once you practice them enough, it starts to sink in. So you just want to use those and practice. Again, that's not always going to work on the EOC because it will have been a very long time since you've done that. I'd rather you build in your own understanding of how to do it instead of just trying to go through and memorize steps and do steps over and over again. Do this, so that's good. And then what's the length, total length? Oh, this one up here. Okay. So 3/4, that's right. You multiply it times that. So what does that 3 represent?
1 segment.
I think you did do the math wrong. It's supposed to be 3 times 16. How'd you get 12? Oh, let's talk about just really quickly while we're dealing with fractions. Everybody look at your calculator, assuming you have this calculator. I'm going to show you something that will possibly save your butt on mainly the district test, but also on a PSAT, although I don't know if you get this exact calculator, but this button works pretty similarly on all calculators.
What? Okay.
This is those over there that I have, but it's on these calculators also. It's the same button. This is a Casio. I think it's on this one also. Yeah, it's the same thing on. They're all the same for this one button at least. Well, The button is the same. I don't know if you put it in the same order. Look at the button for this one. It's right here. It's got a capital A and then a little b and a little c. That does fractions for you right there. So if you hit, so where I'm doing the first problem where you said 3/4 times 16. Hit the button 3. I think this is the way it works. Hit that A, B, C button now. That little, you should see a little mark that looks like this.
Arrow.
Oh, shouldn't be an arrow.
Yeah.
Well, it's like a right angle is kind of what it is, sort of.
Yeah.
And then hit 4. You just typed in 3/4. Now say times, and then put in 16. It'll even give you the answer as a fraction using this same little marking. If it comes out to be a fraction.
What?
Oh wait, that one,
Mine's 12.
yeah, well, that one didn't come out to be. So, but again, so now you have 12, right? So you don't need to divide it by 4. You divided that in by 4. So 3/4 of 16 is 12. So what does that 12 represent? Did you have a question on getting the 12? Did you not get the 12? Okay. So what is the 12 that we just got? What in the world is that? We just said 3/4 of 16. What's the 12 represent? Yeah, that's how long the first segment is. First segment is 12. So the second segment is going to be 4 if the total thing has to be 16. So when you go to put the point on it, you could just count over 12, or you could add 12 to the first number. Either way, that's where the point's going to go. So when you multiply the fraction, which you can now do in the calculator, times the length of the line segment, this will give that to you in either a whole number, if that's what it comes out to be, or it'll give it to you in fraction if it comes out to be a fraction still. And then you would add that, then you can just immediately add that to the first number, and that'll tell you where the point needs to be. So these calculators can save you when it comes to fractions if you don't recall exactly how to do all the different operations with fractions, especially like division and adding them and subtracting. Well, you need to be using it a lot. That's why you really need to practice with these calculators, not with your phone. Phones don't work that way. I don't even know if phones have it. All right, let's look at the next example real quick. It uses a coordinate plane, but it's really the same exact process. It's just you have to kind of do it twice. Because there's 2 numbers we need to get, because now, if you'll notice, I'm not using a number line. This is not a number, this is a number line down here, and this is a number line going up, but the line that I'm going to try to use or try to go from is not a number line. Zoom, I think this will, yeah, that'll work. So if I want to find a point that is 3/5 of the way, and normally it would say from A to B. So I'll make it from A to B. If I want to find a point that is 3/5 of the way from A to B, I can't just use, although I kind of wind up doing this, now I'm not on a number line. I can't just count, because I can't count going this way and say, oh, that's 1, 2, 3. That doesn't work when it's diagonal. That only works when you're counting horizontally or vertically. So here's what you do. Same process. We convert it to a fraction. So we use the first number. So what's the fraction going to be? What's the fraction? From 3/5. I need to use the first number and then put it over what?
The total, so 8.
So again, if you're not getting that immediately, then you got a lot of practice to do this week on your own. So my fraction I'm going to use is 3/8. Now, though, I can't really use the distance of that line because I don't have a starting number and an ending number to subtract, right? Now, there is a way to figure it out if you really, really want to do it the same way we just did it. There is a way to figure it out. I don't think it's the easier way, so I'm not going to teach you that. If you really want to learn it, I can. I'm going to teach you a way that will take a tiny bit longer, but I think it's much easier to understand. We're going to use the 3/8 number, but we're going to do it like this. We're going to imagine that there is a horizontal line there and a vertical line there. And we're gonna use, and these go, if you'll notice, these are basically using the number lines. We're gonna take 3/8 of this number here. So from 1 to 9, and then we're gonna take 3/8 of this number here. So from 2 to 6. And then we're gonna add that to the two starting numbers to come up. Because remember, our point, when we put a point on the line, it's gonna have an X and a Y value, right? You gotta remember that. We're dealing with a coordinate plane now. So what is the coordinate for that point right there, the A point? Dimitri, what's the coordinate for that A point? See it? Need to know how to read them. Like, what's the X and the Y value for A? Yeah, it's 1, 2, right? I go right first and then up 2. So 1, 2. So A is at 1, 2. What's the, I don't even need the B point because A is my starting point no matter what. A is my starting point if I'm going that way for my horizontal number. It's also my starting point if I'm going up. So A is the only one I need. So 1, 2 is what we're going to wind up adding to. We'll add one number to the 1 and then a different number to the 2. So what is my distance of the horizontal line from A to this point here? What's that distance?
A2 all the way to the right.
Yep. So then where the point is right here. What's that distance?
8.
Yeah, it's still subtraction. It's the same exact thing you did. Just ignore all of the stuff going on above it and just treat it like I'm just using this line. I'm going from 1 to 9, right? So I'm going from here to here. Well, how long is that? Well, I subtract 8. So I do the same exact thing I just did before. I take the fraction, I multiply it times the distance of the line. If you do it in your calculator, you should get a 3. So I just created how long is the first little segment. Well, the first little segment should be 3, or I could say 3 plus 1, and I get 4. And you can even check yourself with that. Is this segment 3? 1, 2, 3. Yeah, I'm good. So that's the first part of it. So my new coordinate, if I add 3 to 1, is going to be 4, comma. Now I do that same thing, but how long is the vertical line? The Y value, how long is that line? It's from 6 to 2, right? So I'm going to say 6 subtract 2. If you're not getting this, I'm going fast, I know. You have to go back and watch this and review it or just do a bunch of practice. So I still take the 3/8. Actually, let's do this in blue. So I'm taking 3/8 again.
You think
I actually can do pink. 3/8 times 4. Now, though, that's going to give me a fraction. That's going to give me 1/2. Oh, I'm sorry, 1.5, I believe. Does anybody want to check my math? So I could say, I'm going to say 1.5. So wait, that can't be. Oh, yeah, that's right. Because I'm saying how long is the first part of this segment going up? So I'm dividing this into 2 segments. The first part is going to be 1.5. So if I add the 1.5 to 2, 2 plus 1.5 is 3.5. So I come here to 3.5. Really, all I had to do was go straight up to the line. But I do need to know where that point is at. I can't just put a point on the line. I have to know what the X and the Y value are. So it's the same thing we just did, only we're doing it twice. We're doing it once to get the X value and once to get the Y value, because when you're putting a point on a coordinate plane, you've got to have an X and a Y. It can't just be one number. All right, so you have a couple more, well, about 5 more minutes to practice either what we did before, or if you want to jump to one of these. This is example 3, or like example 3, I believe. I didn't use example 3. Yeah, I didn't use example 3. So if you want to try example 3 where they already worked it out for you, and now you can kind of go through and do it on your own, but you have a little help in the example. But that's what you're going to be responsible for on Monday for this lesson. We still have another lesson to do on a brand new topic on Thursday. Although it's somewhat similar to this because it's midpoint. We're doing midpoint, which we've already kind of done. But then there is one more thing called a bisector that we have to do. That I think we have to use like a compass and do what's called a construction, where you actually physically learn how to create a midpoint and a bisector. I've never taught that before. Taught me personal, because the year I taught geometry was the COVID year, and they didn't want us sharing.
You were looking for the
Compasses.
midpoint, right?
What's that?
You were looking for the midpoint?
No, I was looking for the point that said, oh, that's a good question. Where would the midpoint have been approximately on this? Like, if I divided this line in half, midpoint would have probably been somewhere around there, right? Well, if I'm dividing it in a ratio of 3 to 5, that means I would want to be left of the midpoint. Well, sure enough, I am. So again, that makes sense. That's a viable answer. I don't know why you guys are packing up. I mean, again, this is what drives me crazy. Everybody's going to pack up, and I know some of you don't get this that are packing up. You got it. Again, I don't babysit. But when it comes into the quarter, don't come crying to me about it. There's no extra credit. Now you can do makeups, but makeup process isn't just, oh, I want to make that quick. Like I want to retake. Oh, here's your retake. That's not the process. It will take you a week to get ready, I would bet you, to do the retake. So from the day you tell me, I'm gonna say, okay, you gotta do this, 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 and this. I guarantee you, you're not done with that in a week. So don't think that it's gonna be an easy process to get your grade up. And I saw the grade, I saw some of your sections on that, especially that back page on segments. There are gonna be a lot of retakes. And that's already one retake. So you get behind on retake after retake, there's just no way you're gonna be able to do it. I'm not gonna take retakes all the way up to the last day, because I'm not gonna be stuck trying to get everything graded over a weekend to be able to do the grades the next week. So the last week of class, there probably won't be any retakes. Oh, if you're done, Kristen, is that what you're doing? If you're done, that table over by where Kristen is, I'll leave some stuff. That table, the white table with pencil sharpener, put your books over there. The geometry books, not if you happen to see another book around you, that's algebra, don't worry about that. Just the geometry books for you. There's are just staying. Please be relatively neat when you put them over there. I don't want them falling all over the place, because ultimately then they fall on the floor and I have to clean it up, so. I always need like one really detailed person that likes to straighten them for me. You need to go back and watch that video. I'm telling you guys, I really am worried about my classes for this quarter. I'll post this probably at lunch. I think I might be able to get, although I got to post my 1A video also, and sometimes it takes a little while. So I'll try to get it posted at lunch. So it should be there if you need to review it, if you're concerned, because I'm concerned.